June 6, 1944. The beaches of Normandy ran red with the blood of thousands, yet through the chaos and carnage, American commanders maintained crystal-clear communication across every sector of the invasion. German intelligence officers monitoring Allied frequencies couldn't comprehend how the Americans coordinated such massive troop movements with seeming ease, their radio chatter flowing uninterrupted despite the Wehrmacht's best jamming efforts. 3 weeks after D-Day, Hauptmann Friedrich Weber stood in a converted chateau outside Caen, staring at an olive-drab metal box his men had pulled from a destroyed American half-track. The SCR-300 radio backpack sat on the wooden workbench like a puzzle waiting to be solved. Weber, a communications specialist who had studied electrical engineering at the Technical University of Berlin before the war, had intercepted dozens of American transmissions, but he had never held one of their radios in his hands. "It's remarkably compact," observed Lieutenant Klaus Dietrich, adjusting his spectacles as he examined the device. Dietrich had worked for Telefunken before being conscripted, and his expertise in radio technology made him invaluable to German signals intelligence. "Lighter than our equivalent units by at least 5 kilograms. Weber carefully opened the casing. What he saw inside defied his expectations. German military radios of comparable range were bulky, temperamental machines that required constant adjustment and maintenance. The Torn.Fu B1, their standard infantry radio, weighed nearly 30 kilograms and required 2 men to operate effectively. This American unit could be carried by a single soldier. The chateau's basement had been transformed into a makeshift laboratory, equipped with oscilloscopes, signal generators, and testing equipment salvaged from French telecommunications facilities. Weber's team had been tasked with a singular mission: determine why American radio communications proved so reliable, while German units struggled with interference, equipment failures, and limited range. According to declassified reports from the United States Army Signal Corps Historical Section, the SCR-300 represented a revolutionary leap in battlefield communications technology. Weber didn't know it yet, but he was about to uncover secrets that would haunt German military planners for the remainder of the war. "Begin the frequency analysis," Weber ordered, connecting the radio to their testing apparatus. Obergefreiter Hans Müller, the youngest member of the team at 23, operated the oscilloscope while Dietrich powered up the captured American generator they'd acquired specifically for testing Allied equipment. The radio crackled to life. Static filled the room, then cleared as Müller fine-tuned the frequency. Even without proper antennas, the signal strength seemed impossibly robust. Weber switched between channels, noting how quickly and smoothly the frequency modulation responded. "Frequency modulation instead of amplitude modulation," Dietrich muttered, scribbling notes frantically. "The Allies have standardized FM for tactical communications." Weber nodded slowly, the implications already forming in his mind. German radio doctrine had committed heavily to amplitude modulation, believing it sufficient for military needs. The Americans had taken a different path entirely. But this was merely the first revelation. As Weber would discover over the following weeks, the radio's transmission method was only the beginning of American communication superiority. The real genius lay in what he hadn't yet seen, and what would ultimately prove impossible for Germany to replicate. June 28, 1944. Weber's team had been dissecting American radio equipment for 3 weeks, and each discovery added another layer to their growing astonishment. The chateau's basement now resembled a museum of Allied communications technology, with captured radios, field telephones, and wire equipment arranged on tables like artifacts from an advanced civilization. Dietrich held up a small component no larger than his thumb. "Look at the vacuum tubes," he said, his voice tinged with frustration. "The RCA design uses ruthenium coating on the cathodes. Our tubes burn out after 50 hours of operation. These are rated for 500 hours minimum." Weber examined the tube under magnification. The craftsmanship was extraordinary. Each component showed evidence of precision manufacturing that German factories, now subjected to Allied bombing raids and material shortages, could barely dream of achieving. The glass envelope was thinner yet stronger, the internal elements aligned with microscopic accuracy. "The Americans have industrialized quality," Weber observed bitterly. He'd seen German radio equipment fail in the field countless times. Humidity, temperature fluctuations, rough handling, all could render German communications equipment useless. The American gear seemed designed to withstand punishment that would destroy its German counterparts. Mueller had been documenting every component, creating detailed technical drawings. Herr Hauptmann, the crystal oscillators are temperature compensated, and the frequency stability is maintained across an operating range from -30 to +60 degrees Celsius. This revelation struck Weber with particular force. German radios drifted off frequency in extreme temperatures, requiring constant readjustment by trained operators. In the frozen hell of the Eastern Front or the scorching deserts of North Africa, this limitation had cost countless lives when communications failed at critical moments. Historical records from the Signal Corps engineering laboratories at Fort Monmouth show that American engineers had obsessed over reliability and ease of use. Where German designers assumed trained specialists would operate equipment, Americans designed for the average soldier, perhaps even a frightened, exhausted soldier under fire. Test the durability, Weber commanded. Over the next 3 days, they subjected the SCR-300 to abuse that should have destroyed it. They dropped it from heights of 2 meters onto concrete. They submerged it in water, then dried it out and attempted operation. They exposed it to temperature extremes in a modified industrial oven. The radio continued functioning. Impossible, breathed Dietrich after the 6th destructive test. Our equipment would be scrap metal by now. But Weber had noticed something else, something that transcended mere engineering excellence. The American radio's design philosophy revealed a fundamental difference in how the two nations approached warfare. He pulled out a German Feld Few.B radio and set it beside the SCR-300. Look at the controls, he said, gesturing to both units. Our radio requires extensive training to operate. Frequency adjustment, antenna tuning, power regulation, all manual processes requiring expertise. The American design has preset channels. A soldier simply turns a dial to select his frequency. No technical knowledge required. Dietrich nodded slowly. They've designed for mass warfare, for conscripts and draftees, not career soldiers. Exactly, Weber confirmed. And they've succeeded. He thought of the Wehrmacht's communication doctrine, which relied heavily on telephone wire and runners because German radios were too complex for rapid deployment. Meanwhile, every American infantry company seemed to possess reliable radio communications. The investigation was far from complete. But already Weber understood that Germany faced an adversary whose technological sophistication and manufacturing capability exceeded their own. The question was no longer whether American radio gear was superior. That much had become painfully obvious. The real question was why this superiority existed, and whether Germany could possibly respond before the war's outcome was decided. July 15, 1944. Allied forces had broken out from Normandy, and the sound of artillery echoed across the French countryside even as Weber's team continued their analysis. They had acquired 3 more American radios, another SCR-300, an SCR-536 handheld unit, and a vehicle-mounted SCR-506. Weber spread the technical manuals across the table, captured documents that provided more insight than weeks of reverse engineering. They're interoperable, Miller announced, looking up from the frequency charts. Every radio operates on the same frequency bands. The infantry handheld can communicate directly with the vehicle-mounted unit, which can communicate with the backpack radio. It's a complete network. Weber had suspected this, but seeing the evidence laid out so clearly drove home how fundamentally different American communications doctrine was from German practice. The Wehrmacht employed dozens of different radio types, many incompatible with each other. Artillery units couldn't directly communicate with infantry. Tank commanders used different frequencies than ground troops. Coordination required relay stations and complicated procedures. "Read me the specifications again," Weber requested. Dietrich consulted his notes. The SCR-300 operates between 40 and 48 MHz with 40 preset channels, range of approximately 5 kilometers under normal conditions, up to 8 kilometers with favorable terrain. The SCR-536 handheld covers the same frequencies but with reduced power output. The SCR-506 vehicular unit extends range to 15 kilometers. All frequency modulation, Weber added, resistant to interference and static. He thought about German amplitude modulation systems, vulnerable to atmospheric conditions and easily jammed. The Americans had chosen FM precisely because it offered clear, reliable communication even in difficult conditions. But standardization went deeper than compatible frequencies. As Weber examined the components from multiple radios, he noticed something remarkable. Many parts were identical across different models. A vacuum tube from the SCR-300 could be installed in the SCR-506. Power supplies used the same voltage specifications. Even the battery connections followed a universal standard. They can scavenge parts from damaged radios to repair working units, Dietrich observed. A logistics officer's dream. According to documentation from the Army Signal Supply Agency, preserved in the National Archives, American military planners had deliberately standardized components across their entire communications inventory. This decision, made years before Pearl Harbor, had enabled the rapid expansion of military communications that supported operations across Europe and the Pacific simultaneously. Weber considered the implications for field maintenance. German radio operators carried specialized tools and spare parts unique to each radio model. American soldiers could perform basic repairs with common tools and interchangeable components. In a protracted campaign where supply lines stretched across continents and oceans, this advantage proved decisive. Test the power requirements, Weber ordered. They'd already noted that American radios could operate on multiple power sources: batteries, vehicle electrical systems, or hand-cranked generators. German equipment was far less flexible. Mueller connected the SCR-300 to various power sources throughout the afternoon. The radio performed equally well on its standard batteries, a captured American Jeep's electrical system, and even a British generator they'd acquired from another intelligence unit. The voltage regulation circuitry automatically compensated for variations in power supply. Brilliant engineering, Mueller admitted grudgingly. They've eliminated the most common sources of equipment failure. Weber lit a cigarette, a habit he'd developed since beginning this investigation. The smoke curled toward the chateau's vaulted ceiling while he contemplated the growing evidence of American technological superiority. Each discovery reinforced a disturbing conclusion. Germany was fighting an enemy whose industrial capacity and engineering sophistication far exceeded their own. The standardization extended beyond the radios themselves. The technical manuals were clear, well illustrated, and written for operators with minimal technical training. German manuals assumed extensive knowledge of radio theory. American manuals provided step-by-step instructions accompanied by simple diagrams. They've democratized technology, Dietrich said quietly, made it accessible to common soldiers. While we've kept it the province of specialists, Weber finished. He crushed out his cigarette. And now we're paying the price. August 2nd, 1944. The situation on the Western Front had deteriorated catastrophically for German forces. Operation Cobra had shattered Wehrmacht defenses, and American armored divisions were racing across France. Yet in his basement laboratory, Weber continued his investigation, driven by professional curiosity and a grim determination to understand the full scope of Germany's predicament. A new shipment had arrived, radio equipment pulled from a destroyed American signals truck. Among the items were spare parts inventories, maintenance logs, and supply requisition forms. These mundane documents revealed truths more devastating than any battlefield defeat. "Listen to this," Weber said, translating from the English requisition form. This signals company requisitioned 150 SCR-300 radios in March of 1944 alone. 150 radios for a single company. He looked at his team. "Do you know how many equivalent radios the entire Wehrmacht produced last month?" Dietrich checked his intelligence briefing documents. Approximately 300 Torn FU units across all models for the entire armed forces. The silence that followed was profound. Weber set down the document and walked to the window, gazing out at the French countryside. Somewhere beyond the horizon, American factories were producing radios by the thousands, while German manufacturing struggled to maintain even basic production levels under constant Allied bombing. Müller had been examining the spare parts inventory. Herr Hauptmann, they carry enough spare tubes and components to rebuild each radio twice over. And according to this log, they receive new parts shipments weekly. Weekly, Weber repeated. German radio operators were often told to make do with failing equipment because replacement parts wouldn't arrive for months, if they arrived at all. Meanwhile, American supply sergeants requisitioned components as casually as they ordered rations. The maintenance logs told another story. American radio operators performed regular preventive maintenance on scheduled intervals, replacing components before they failed. German doctrine advocated for using equipment until it broke, then attempting repairs, a necessary approach given chronic part shortages, but one that guaranteed communications failures at the worst possible moments. Research materials from the Industrial College of the Armed Forces, documented in post-war studies of military logistics, demonstrated that American production capacity exceeded German capabilities by factors of 10 or more in most equipment categories. By mid-1944, American factories produced radios as readily as Germany produced rifles. Weber examined a production stamp on an SCR 300 casing. Galvin MFG Corpimauern, Chicago, April 1944. The company that would later become Motorola had manufactured this specific unit just 3 months earlier. It had crossed the Atlantic, equipped an American soldier, survived combat operations, been captured, and now sat on Weber's workbench. All within a single season. The logistics are as impressive as the technology, Dietrich observed. They've created a supply chain that delivers equipment from American factories to frontline soldiers in weeks. Our supply system takes months even for domestic shipments. Müller held up another document. This is a simplified technical manual intended for forward maintenance technicians. It provides troubleshooting procedures using flowcharts rather than technical descriptions. Any mechanic can follow it. Weber took the manual, studying the clear illustrations and step-by-step instructions. He compared it to a German technical manual for the Feldfew B, dense paragraphs of technical specifications that assumed the reader possessed advanced knowledge of radio theory. They've systematized everything, Weber concluded. Production, supply, maintenance, operation, every aspect of their communications infrastructure is designed for efficiency and scale. We're still thinking like craftsmen, producing limited quantities of sophisticated equipment. They're thinking like industrialists, producing vast quantities of reliable equipment. The implications extended far beyond radio communications. If American industrial capacity dominated in this one category, it likely dominated across the entire spectrum of military equipment. Tanks, aircraft, artillery, vehicles, all probably followed the same pattern of mass production and efficient logistics. We cannot win this war, Dietrich said quietly. It was the first time anyone had spoken the thought aloud, though Weber suspected they'd all been thinking it. Weber didn't respond immediately. As a professional soldier, his duty was to his nation and his comrades, regardless of his personal conclusions about the war's ultimate outcome. But as an engineer and analyst, he couldn't ignore the evidence before him. Germany faced an enemy with virtually unlimited resources and the organizational capability to transform those resources into battlefield superiority. August 23, 1944. Paris would fall to Allied forces in 2 days, though Weber didn't know it yet. His team had relocated to a facility outside Metz as American forces advanced across France. The investigation continued, now supplemented by interviews with captured American radio operators and Signal Corps personnel. Private First Class Robert Morrison sat across from Weber in the interrogation room, looking nervous but not terrified. The young American had been captured 3 days earlier when his jeep broke down behind German lines. He was 19 years old, had completed radio operator training in 8 weeks, and had been in France for less than a month. How many hours of training did you receive on the SCR 300? Weber asked in accented but fluent English. He'd studied at Oxford for a semester before the war, a fact that now seemed to belong to another lifetime. About 40 hours total, sir. Morrison replied. But most guys can learn the basics in a couple days. It's not complicated. Not complicated, Weber repeated. He thought of German radio operators who required months of training, many of them recruited from technical schools or universities. You can operate the radio reliably after just a few days? Morrison shrugged. Sure. You turn the dial to your assigned channel, press the transmit button and talk. If something goes wrong, you check the troubleshooting card in the manual. If that doesn't work, you swap in a new tube or replace the batteries. Pretty straightforward. Dietrich, observing the interview, leaned forward. What happens if your radio is damaged in combat? Request a replacement, Morrison answered. Usually get one within a day or two. If it's urgent, they airlift it in. We never go long without communications. This casual confidence represented perhaps the most significant difference between American and German forces. Morrison genuinely believed that if his equipment broke, it would be replaced quickly. German soldiers had no such expectation. Equipment losses were permanent. Damaged radios were laboriously repaired rather than replaced. Tell me about your training, Weber requested. Over the next hour, Morrison described the American Signal Corps training program. The young soldier had been a grocery clerk in Ohio before the draft. The Army had transformed him into a radio operator in less than 3 months, using standardized training programs that could be replicated across dozens of facilities. According to Army Service Forces training manuals, excerpted in military education journals, American training philosophy emphasized practical skills over theoretical knowledge. Soldiers learned to operate equipment through repetition and hands-on practice, not academic study. The approach produced operators who might not understand radio theory but could reliably perform their missions under combat conditions. We had this saying, Morrison continued, any idiot can use this radio. And it's kind of true. I've seen guys who barely graduated high school operate these things perfectly. Weber exchanged glances with Dietrich. German military doctrine assumed that complex equipment required intelligent, educated operators. American doctrine assumed the opposite. Equipment should be simple enough for anyone to use. This philosophical difference drove every aspect of radio design and training. What about maintenance? Mueller asked. We've got maintenance guys who handle the complicated stuff, Morrison explained. But for basic problems, we can fix it ourselves. The manual tells you exactly what to do. It's like following a recipe. The interview concluded, and Weber had Morrison return to the prisoner compound. The American would likely spend the rest of the war in a POW camp, far from the battlefields where his countrymen were methodically destroying the Wehrmacht. He's not exceptional, Dietrich observed once they were alone. Just an ordinary young man who received adequate training on well-designed equipment. Yet he's more capable than many of our specialized communications personnel. Weber nodded. The Americans have democratized military technology. They've created systems that transform ordinary citizens into effective soldiers. We, meanwhile, rely on exceptional individuals to compensate for inadequate systems. This realization cut deeper than discoveries about frequency modulation or component standardization. The true genius of American military communications wasn't technological. It was human. The Americans had designed their entire system around the assumption that common soldiers, not technical specialists, would operate equipment under combat stress. Every decision, from radio design to training methodology to logistics support, reflected this central philosophy. We cannot replicate this, Miller said. Even if we captured enough radios to reverse engineer them, even if our factories could match American production levels, we cannot duplicate their entire system. It's too comprehensive, too deeply integrated into their military culture. Weber lit another cigarette. No, he agreed, we cannot. September 12, 1944. Allied forces had reached the German border, and the reality of impending defeat hung over every Wehrmacht installation like a shroud. Weber's team had been ordered to prepare a comprehensive report on American communications capabilities for Army High Command. The Chateau Laboratory now contained enough captured equipment to outfit an entire signals company. Dietrich had arranged 3 radios on the workbench in a configuration that mimicked American tactical deployment. The genius isn't in individual radios, he explained to Weber. It's in how they function as a network. He activated the first radio, an SCR-536 handheld unit. Infantry squad leader carries this, range of approximately 1 kilometer to the next level of command. He turned to the second radio, an SCR-300 backpack model. Platoon leader has this, can communicate with multiple squad leaders and with company headquarters. Finally, he indicated the SCR-506 vehicle-mounted unit. Company commander uses this, links to battalion and can relay messages across the entire communications net. Hierarchical but flexible, Weber observed. Each level can communicate up and down the chain of command. And horizontally, Miller added, pointing to the frequency charts. Adjacent units use different channels but can switch frequencies if necessary for coordination. The entire division operates as a single communications network. Weber had studied enough American tactical doctrine to understand the implications. German communications were rigid, following formal chains of command. Information flowed up to headquarters, decisions flowed back down. The process was methodical but slow. American communications doctrine encouraged lateral communication and initiative at lower levels. Squad leaders could coordinate directly with adjacent squads. Platoons could communicate across company boundaries when tactical situations demanded it. Documentation from the Office of the Chief Signal Officer, preserved in historical archives, shows that American planners had deliberately designed a resilient, redundant communications network. If one node failed, others automatically compensated. Messages could be routed through alternate channels. The system degraded gracefully under stress rather than collapsing catastrophically. "Watch this," Dietrich said. He had Müller take the handheld radio to the chateau's third floor while he remained in the basement with the SCR-300. The vehicle-mounted unit sat in a captured American truck parked outside. Using different frequencies and relay procedures, Dietrich demonstrated how a message could travel from basement to third floor, to vehicle and back again, through multiple routes. Redundancy and flexibility, Weber noted. If any single radio fails, the network continues functioning. Exactly. And because all units use compatible equipment, any radio can substitute for any other radio in an emergency. Compare this to our systems, where specific radio types serve dedicated functions. If a critical unit fails, we have communications breakdown. Weber thought about the countless occasions when Wehrmacht operations had been hampered by communications failures. Artillery strikes delayed because radio equipment malfunctioned. Infantry advances stalled waiting for orders that never arrived. Tank formations isolated from their supporting units. Each failure had cost lives and advantages on the battlefield. The Americans had solved these problems not through superior individual components, but through systemic design. Their radios were good, but the real innovation was in how those radios worked together as an integrated whole. They've created an information advantage, Weber concluded. American commanders at every level know more about battlefield conditions than their German counterparts. They can make decisions faster, coordinate more effectively, and adapt to changing circumstances more rapidly, all because their communications networks function reliably. Miller had been reviewing captured American after-action reports. "Look at these response times," he said, passing documents to Weber. "From initial enemy contact to artillery support, typically 8 to 12 minutes. Our equivalent times are 30 to 45 minutes, and that's on operations where communications function properly." Weber studied the reports. The Americans used their communications advantage to devastating effect. Observers called for artillery fire that arrived before German units could dig in. Infantry commanders coordinated flanking maneuvers, while German formations were still trying to establish contact with higher headquarters. Tactical air support responded to ground requests within minutes rather than hours. Information flows freely through their system, Dietrich observed. In our system, information is tightly controlled following rigid protocols. They've sacrificed formality for speed. This represented another fundamental philosophical difference. German military culture valued hierarchy and formal procedures. American culture valued results over process. Neither approach was inherently superior, but combined with technological advantages, the American system proved devastatingly effective in modern mechanized warfare. Weber began drafting his report for Army High Command. He knew it would make little difference, Germany lacked the resources to replicate American communication systems, even if military leadership accepted his conclusions. But professional duty required honest assessment, however grim the implications. We are fighting an enemy who sees the battlefield more clearly, thinks more quickly, and acts more decisively than we can, Weber wrote. Their communication superiority enables all of this. October 8, 1944. Weber's team had been recalled to Berlin to present their findings directly to high-ranking military officials. The journey through a Germany under constant Allied bombardment had reinforced everything Weber had learned about American material superiority. Factories lay in ruins, transportation networks barely functioned, supply chains had collapsed into chaos. The briefing room in the Reich Chancellery bunker felt oppressive, lit by harsh electric lights that made everyone look ill. Weber stood before a collection of generals and technical specialists, his carefully prepared charts and diagrams arranged on easels. On a table sat 3 captured American radios and 1 German equivalent radio, physical evidence of the technological gap he was about to describe. "Gentlemen," Weber began, "I will not waste your time with reassuring falsehoods. American radio communications capabilities exceed our own in every measurable category: reliability, range, ease of use, production capacity, and tactical integration. This superiority has directly contributed to Allied battlefield successes." The generals shifted uncomfortably. General Oberst Heinrich, Chief of Army Communications, frowned deeply. "Surely you exaggerate, Hauptmann. German engineering is the finest in the world." "Our engineering tradition is excellent," Weber agreed carefully. "But engineering excellence and industrial capacity are not the same thing. May I demonstrate?" He picked up the SCR-300 and the German Tornfew B-1, setting them side by side. The American radio weighs 15 kilograms and can be operated by a single soldier with minimal training. Our equivalent weighs 28 kilograms and requires extensive technical knowledge. The American unit uses frequency modulation, making it resistant to interference. Our unit uses amplitude modulation, which is vulnerable to atmospheric conditions and jamming. Weber proceeded through his presentation methodically, detailing every advantage he'd discovered: standardized components, reliable vacuum tubes, interoperable frequencies, simplified operation, comprehensive logistics support, efficient training programs, and network integration. "The Americans have created a complete system," Weber emphasized. "Their radios are excellent, but the true advantage lies in how they've integrated technology, training, logistics, and doctrine into a unified whole. We cannot defeat this system by improving our radios alone. We would need to transform our entire approach to military communications." According to declassified Wehrmacht communications assessments, documented in post-war historical research from the Militärgeschichtliches Forschungsamt, Weber's briefing represented one of the most comprehensive analyses of Allied technological superiority produced during the war. His conclusions were accurate, thoroughly documented, and completely ignored by military leadership. General Oberst Heinrich interrupted. "What you describe would require years to implement and resources we do not possess. What can be done immediately?" "Very little, I'm afraid," Weber answered honestly. "We can attempt to jam American frequencies, but FM communications are difficult to interfere with effectively. We can try to capture more American equipment for our own use, but we lack compatible training and logistics support. We can prioritize radio production, but our factories cannot match American output even under optimal conditions." "You're saying we're helpless?" another general demanded. "I'm saying we face an adversary whose industrial capacity and technological sophistication exceed our own," Weber clarified. "This is particularly evident in communications equipment, but I suspect the pattern applies across all military hardware. They can produce more, deliver faster, and maintain better than we can." The briefing lasted 3 hours. Weber answered questions about technical specifications, production capabilities, and tactical implications. He provided realistic assessments of Germany's ability to respond, which ranged from difficult to impossible depending on the specific capability in question. At the conclusion, General Oberst Heinrich stood. "Your report will be forwarded to the appropriate authorities. Dismissed, Hauptmann." Weber saluted and left the bunker. Walking through bombed-out Berlin streets, he reflected on the futility of his investigation. He'd answered the question of why Americans never lost contact. Superior technology, massive production, efficient logistics, practical training, and integrated systems. But knowing the answer changed nothing. Germany was losing the war not because of individual failures or tactical mistakes, though there had been plenty of both. Germany was losing because it faced enemies who possessed greater resources, stronger industrial bases, and more effective systems for transforming those advantages into battlefield superiority. American radio communications were merely one visible manifestation of a deeper imbalance. Dietrich and Mueller met him at a cafe that somehow remained operational, despite the devastation surrounding it. They drank ersatz coffee made from roasted grain and said little. What was there to say? They'd performed their duty, documented the truth, and delivered conclusions no one wanted to hear. "Do you think anything will come of your report?" Miller asked finally. Weber shook his head. "No. The information will be filed away and forgotten. Perhaps some officer will read it after the war and wonder what might have been different if we'd understood these things earlier." May 8, 1945. The war in Europe had ended. Weber stood in an American POW camp in Bavaria, watching Allied soldiers celebrate victory. The irony wasn't lost on him. He'd spent months studying American communications equipment, and now he was surrounded by the very systems he'd analyzed. An American signals officer, Captain James Harrison, had requested to speak with him. Harrison had somehow obtained a copy of Weber's October report, translated by German-speaking intelligence personnel. They sat across from each other in an interrogation room that now served as an informal conference space. "Your analysis was remarkably accurate," Harrison said, pushing the translated document across the table. "Our post-war review teams have been interviewing German officers about Allied capabilities. Your report is one of the few that got almost everything right." Weber studied the document, seeing his own words translated into English. "I had excellent equipment to examine and time to study it properly. The conclusions were obvious to anyone with technical training. But not obvious to German high command, apparently," Harrison observed. "Why do you think they ignored your findings?" "Because acting on them would have required admitting that Germany couldn't win the war," Weber answered. "No military leadership wants to accept that conclusion while the fighting continues. Easier to hope for secret weapons or political developments that might change the strategic situation." Harrison pulled out a fresh pack of American cigarettes, Lucky Strikes, and offered one to Weber. They smoked in companionable silence for a moment. Two technical specialists who'd been on opposite sides of a war neither had chosen to fight. "We're interviewing German technical personnel about their equipment and methods," Harrison explained. "Part of post-war intelligence gathering. Would you be willing to participate? We're particularly interested in German radio development efforts and why certain design choices were made." Weber considered. As a prisoner of war, he had limited bargaining power, but he also had valuable information. "I'll cooperate, but I want something in return. Information. I'd like to know if my analysis was truly comprehensive. Were there aspects of American communication superiority that I missed?" Harrison smiled. "Fair enough." Over the next several hours, he explained details Weber had never discovered. The massive training infrastructure that produced thousands of qualified radio operators monthly, the specialized maintenance depots that could rebuild radios in hours, the radio nets that linked ground forces with tactical air support and unprecedented coordination, and the emerging technologies that would dominate post-war communications. "The SCR-300 that you studied so carefully was already becoming obsolete by 1945, Harrison revealed. "We were testing improved versions with better range and reliability. The industrial momentum we'd built up during the war meant we could continually upgrade and improve our equipment." This information confirmed Weber's worst fears. Even if Germany had somehow duplicated American radio technology, the Americans would have already moved on to newer, better systems. The industrial and technological gap wasn't static, it was widening. According to records from the U.S. Army's Office of Military History, preserved in the Center of Military History Archives, Weber's cooperation during debriefing sessions provided valuable insights into German perspectives on Allied technological advantages. His detailed understanding of American equipment helped post-war analysts appreciate how comprehensively Allied industrial superiority had manifested across all military domains. In the months that followed, Weber participated in extensive technical debriefings. He described German radio development efforts, explained why certain design choices had been made, and provided insights into Wehrmacht communications doctrine. The Americans were methodical, thorough, and unfailingly professional. They treated him as a fellow engineer rather than a defeated enemy, and he responded with equal professionalism. One evening, Harrison shared an observation. "Your report concluded that Germany was fighting an enemy with superior resources and better systems. You were right, of course. But I think you understood something deeper. That modern warfare isn't just about courage or tactical skill anymore. It's about integrated systems, technology, logistics, training, and doctrine all working together. The side that masters these systems wins, regardless of individual bravery." Weber nodded slowly. "Yes, that was precisely my conclusion. I watched American soldiers who were no more courageous than their German counterparts, fighting with equipment that was no more technologically sophisticated than German designs in theory. Yet they won consistently because every aspect of their military system functioned more effectively than ours." By late 1945, Weber was released from the POW camp. He returned to a shattered Germany that would take decades to rebuild. He never worked in military communications again. Instead, he found employment helping to reconstruct German telecommunications infrastructure, applying lessons learned during the war to civilian applications. Years later, in 1963, Weber received an unexpected letter from Harrison, now a colonel involved in developing military communication systems for the Cold War era. Harrison had located him through former contacts and wanted to let him know that Weber's wartime analysis had influenced American military communications doctrine in surprising ways. "Your report helped us understand how our own systems were perceived by technically competent adversaries," Harrison wrote. "It reinforced the importance of integrated design, standardization, and user-focused engineering. Some of the principles you identified in our World War II equipment continue to guide military communications development today," Weber wrote back, expressing appreciation for the contact. He reflected on how strange it was that his analysis of American radio gear had contributed, in a small way, to post-war military technology development. The radios he'd studied so carefully in that French chateau had been just one manifestation of American industrial might, but they'd revealed fundamental truths about modern warfare that remained relevant 20 years after the conflict ended. The captured SCR-300 that had started his investigation now sat in a museum, an artifact from a war that had transformed the world. Weber never saw it again, but he never forgot what it represented. Not just a superior radio, but a superior system, and a glimpse into how nations would fight wars in the technological age.